So for this next section, we're going to evaluate each of the following given the function f of x equals 6x squared minus x plus 4. This is supposed to be an easy section, lots of giving points. The biggest problem people will have is not following their PEMDAS. Now I put the P, E, M, and D is multiply and divide. I put that on top of each other because that's really only one step, and then A and S. Don't forget you're going left to right. So please follow your PEMDAS. That's the only way people usually mess this one up. So if I'm trying to do f of 4, that means every time I plug in, every time I see an x, so I have 6x squared, instead of the x, I'm going to plug in a 4. Then it's minus x plus 4. Again, every time I see an x, I'm going to plug in a 4. Once I have this correct, inside the parentheses, there's not much I can do. There's nothing I can do with the 4 or the 4. But the exponents, I can do e exponents. 4 squared, that's 16. So that's 6 times 16. I'm just going to leave everything else the same. 6 times 16, that is 96. So now we have 96 minus 4 plus 4. Going left to right, I'm going to do my add and subtract. Now, sometimes people think A comes before S, and so therefore you're supposed to add and then subtract. That's not true. Add and subtract are on the same step, so I'm just going to add and subtract left to right. 96 minus 4 is 92, and then 92 plus 4 is 96. So therefore, f of 4 is equal to 96. And then someone usually raises their hand and asks, hey, do I really have to write the f of 4 equals 96? No, if you just write 96 and box that as your answer, that's fine. You're going to give you credit for it. But f of 4 equals 96 is the proper way of writing it. On the next problem, we have f of negative 3. So every time I see an x, I'm going to plug in a negative 3. So let's see. It's negative 6 times negative 3 squared minus negative 3. So PEMDAS, there's nothing I can do inside the exponents, inside the parentheses, but then I can do exponents. Negative 3 squared is 9 minus a negative 3 plus 4. And then multiply and divide, I can do some multiplication here. 6 times 9, that's 54. We can also do another bit of multiplication. Minus a negative. Minus a negative, we add a line, change the sign. That's really plus 3. Then left to right, 54 plus 3, that's 57. 57 plus 4 is 61. So therefore, f of negative 3 is equal to 61. On our next set of problems, we have a piecewise function, which means g of x is split into two rules. The top rule, negative 7x plus 4, if x is less than 0. And then the bottom rule is x cubed plus minus 2x plus 1 if x is greater than or equal to 0. So when I plug this in, I'm looking at the negative 3 and I'm determining, before I even plug it in, does it belong in less than 0 or does it belong in greater than or equal to 0? In this case, it belongs in less than 0 because negative 3 is less than 0. So when I plug in g of negative 3, I am only plugging it in to the correct function. If you plug it into both functions and just hope that I'm going to pick the right one, I'm not going to give you any credit. If I see two answers here, that means you don't know what you're doing. So make sure you're only plugging it into the correct one. 21 plus 4, that is 25. So therefore, g of negative 3 is equal to 25. Don't plug in the other one. On our next problem, I'm deciding, is 0 less than 0 for the first domain, or is it greater than or equal to 0? Well, 0 is greater than or equal to 0 because of the or equal to. So I am only going to plug 0 into the second rule, x cubed minus 2 times x plus 1, but I plug in 0. Gives me 0 minus 0 plus 1, which is 1. So g of 0 is equal to 1. Don't try to plug it into the other one and hope that I just guess the right one. I won't. I'll pick the wrong one. So on the next one, g of 2. Okay, is 2 less than 0 for the first domain, or is it greater than or equal to 0? Well, this time x is greater than or equal to 0. 2 is greater than 0. So therefore, I'm plugging it into the bottom rule, which is x cubed minus 2 times x plus 1. Don't forget your PEMDAS rules, which say you're going to add and subtract left to right. So 8 minus 4 left to right is 4, then 4 plus 1 is 5. So therefore g of 2 is equal to 5. Our next problem says graph the piecewise function. So I'm going to graph this in 3 different colors just to be super clear here. You can bring 3 different colors to the exam if you really want to, or however you want to do it. So I've got blue, red, and green. So for the red part, the first thing I want to do is pick values that are in the x domain of x is less than 0. So I can pick only things less than 0, like -1, -2, -3, ... But I also have to pick one more thing, and it confuses some people sometimes. I have to pick 0 because that's the endpoint. But I need to make a note that this is not actually in my domain, it's just the boundary of the domain, so therefore that point is going to be open. For the blue area, the domain, I have only one point, x is equal to 0, so that's the only one I have. Now that is truly part of my domain, so that 0 is closed. And then for the next one, I'm looking for domains that are greater than 0. So like 1, 2, and 3. Now that can keep going, but I just can't go forever. In addition, I have to graph the boundary point so I know where to stop and start. The boundary point is 0, although 0 isn't actually in the domain, so I want to make a note that this is going to be open. Okay, this is, I think, the hardest part of the whole thing. Once you got this, then all you have to do is plug it back into the equation. So -3 squared, that's +9. -2 squared, that's +4. -1 squared is 1, and 0 squared is 0. So if I plot these things, at 0, 0, don't forget, we need to make that an open circle. So make sure that's clearly open. Beautiful. Okay, so that looks like a parabola. Don't draw this for a second, but you can kind of see that it's a parabola, but you only see half of it, okay? So we just see the part that is less than 0. For the blue portion, we only have one point. If I plug in 0, I get out just 5, and that's it. That's the only thing I have there. Okay, just one dot, because there's only one domain. In the green function, I have 2x minus 3. So when I plug this in, 2 times 0 minus 3, 2 times 1 minus 3, 2 times 2 minus 3, and 2 times 3 minus 3. Let's see, the first one gets me -3. 2 times 1 is 2 minus 3, that's -1. 2 times 2 is 4, and 4 minus 3 is +1. 2 times 3 is 6, and 6 minus 3 is 3. So at 0, -3, I have an open circle. At 1, -1, at 2, 1, and at 3, 3. Notice this is a straight line. Everything is linear, so I'm going to go ahead and graph that. Put an arrow at the end, which means there's more points to be plotted, but I don't have time to do a million points. Once I get the picture, I can just draw a straight line and do the arrow. The arrow says, and it keeps on going. And then our next problem, we have evaluate the difference quotient for this given function. Now, I didn't make you memorize this difference quotient. This is important in calculus, and you will have to memorize this once you get to calculus, but in this class, I didn't make you memorize it. All I'm making you do is plug it in correctly. This first part, f of x plus h, is a little bit tricky, so I usually like to do that one first. I like to spend a lot of time just making sure that part is correct before I actually plug it in with all of the rest of the parts. So when I plug x plus h in, every time I see an x, I'm plugging in x plus h. Because the x plus h is squared, that's going to take me a minute to write that out twice and double distribute. So I have x times x, which is x squared. X times h, that's xh. H times x, that's again xh. I don't really care which order you plug them in, just make sure you have both xh's. And I would put it in the same order, whichever order you chose to do it in, just put it in the same order. That way on the next step, we could see that these two are like terms, xh and xh. They do add up to two xh's, or hx's. The order of the variables doesn't really matter all that much. Okay, so that was a lot of work, and I have a lot of terms. So I'm going to go ahead and move over x squared plus 2xh plus h squared minus 5x minus 5h plus 7. And all that is just for that first term f of x plus h. Okay, now I have to subtract the original problem. Don't forget that your original problem needs to go in parentheses. The reason it has to go in parentheses is because you're subtracting not just the first term of the function, you're subtracting all terms of the function. This is all over h. So this is a lot of terms, and you're going to have to rewrite them all over again after you distribute the negative. But it is all worth it because it's going to come out real nice here. So when I distribute this negative, that's going to get me all of the red terms minus x squared minus, plus 5x, because a negative times a negative is a positive 5x. A negative times a positive 7, that's a negative 7. This is all over h. Okay. Now, all of these green terms, now that we've distributed, are negative, should all add to 0 with some of the red terms, making this very long expression much shorter in the numerator. So we have x squared minus x squared, one red and one green, add to 0. And then we have minus 5x plus 5x, that adds to 0. And then plus 7 minus 7, that adds to 0. So all I have left here is 2xh plus h squared minus 5h over h. Notice everything in the numerator has an h in it. So because all of the terms in the numerator have an h in it, let's factor out an h. So that gives me 2x plus h minus 5, still all over h. So now that the h's are factored out, they're multiplied. Because they're multiplied, I can do the opposite, which is divide, and I divide out to 1 because they're the same. Therefore, my final answer is 2x plus h minus 5. I know this sounded like a tedious exercise here, but it's really actually very important when you go into calculus. It's one of the first things that you'll end up doing in the first couple units of calculus. So you'll need to have the algebra down so that when you get to calculus, you know what you're doing.